Okay, we're here. Go to math.com. Let's go down to concavity. We're doing, whoa, what is that? Find the concavity of the graph. 7.1, it looks like. Okay. And this looks like a good picture here. Find the concavity of the graph. Now we got a couple inflection points here that we need to know. And then, of course, these points here aren't inflection points, but this is where the concavity, it's not changing. As you can see, we're going to have concave down here and then concave down again. Okay, but this is actually an undefined point on the second derivative, and we'll see that here in just a minute. Okay, so let's go ahead, write this down. Alright, so hopefully you got that written down. If not, I'll be rewriting it. And I don't really like green, so we're going to be doing a different color. Once again, I didn't like that green anyway. Well, we just had Halloween. How about we better just go back to something else, like here. We'll do this color here. How's that? We have f of x. This looks like purple. Is equal to 2, and I'm going to go ahead and rewrite this into the exponential form. We have x squared minus 16, and it's raised to the 2/3 power, and minus 9. Okay, so the first thing we'll want to do, obviously, is take the derivative. So bring out 2/3 out front, we end up with 4/3. X squared minus 16. Subtract 1 from that, we're going to get a negative a half. Okay, because a negative a third. I don't know what I was thinking there. I think I just need to erase that and put that there. Okay, and then the derivative of the inside, bring it out, and that's going to be 2 over, or 2x, right? Derivative of x squared is 2x. Okay, and let's go ahead and man, this is going to be terrible. Let's go ahead and rewrite this. We're going to have 8x over, and because we're going to be using the quotient rule on this next one, squared minus 16 raised, or yeah, raised to the 1/3 power, f prime of x. All right. Okay, so what we're going to end up with now is using the quotient rule. We'll have to use the quotient rule. So we have f double prime of x is equal to, so we take the derivative of the numerator, and that's just 8. Okay, and you know what, let's this 3 is going to get complicated here. Let's just go ahead and bring the 3 up into the numerator. Okay, let's just do that and get it out of the way. Okay, we can do that. We rewrite the denominator, so we have x squared minus 16, and that's raised to the 1/3 power, minus, now we're going to rewrite the numerator. Now, of course, I went ahead and brought 3 up. Alright, brought it up in there. And now we take the derivative of the denominator. So that's going to be bringing 1/3 out front. Rewrite everything in parentheses. Subtracting 1 from the numerator, so that gives us negative 2/3. Right, negative 2/3. And then we take the derivative of what's in parentheses and bring it out, so that's just 2x. Right, and then that's going to be all over x squared minus 16 raised to the 2/3. And the reason why it's raised to the 2/3 is because I squared the denominator, right? And basically you're multiplying 2 times 1/3 to give us 2/3 there. Okay, so this is not going to be our little 5-minute problem here, but I hope you didn't expect that. We have f double prime of x. Now, what I'm going to do here is try to simplify this thing down best I can. And one of the ways of doing that, obviously, is to factor this thing out. We have an 8/3, we have an 8/3, we have an x squared minus 16 in both these. However, we want to factor the one out that's got the smallest exponent, okay, the smallest exponent. And so we're going to go ahead and pull out 8/3. And then what we'll want to do is pull out x squared minus 16 raised to the negative 2/3. Okay, we're going to go ahead and pull the one out with the smallest exponent. And I'll do a bracket here to separate. So we pulled out the 8/3. Now, this is going to be just left with 1. So we have x squared minus 16. And of course, this would be all raised to the first power, but we don't need to do that, right? And so we have minus. Now I pulled out the 8/3. We have x times x, so that's going to be x squared. We have a 2 and 1/3, so that's going to be 2/3. So I'm just going to write 2/3 here. X squared. And then of course we pulled all of this completely out. Okay, we pulled all that out. So let's just do that. And it's all over x squared minus 16, and that's all raised to the 2/3 power. Okay, so we take our time, we don't make any mistakes now. Now what we've got going on here is we're going to go ahead and bring that down into the denominator. So we're going to have 2/3 down here. And since both the bases are the same, we have 2/3 plus 2/3 is, what is 2/3 plus 2/3, right? 4. Okay, so we're going to have 8/3. I'm going to leave this 8/3 up here in the denominator. And what do we got going on here? We have x squared minus 2/3 x squared. So this is going to end up being what? 1/3? 1/3, I guess. 1/3 x squared minus 16. And the denominator, okay, it all looks good. X squared minus 16, and then this was going to be raised to the 4/3. Because when we bring this down into the denominator, right, you have 2/3 plus 2/3, which is 4/3. And we're left with f double prime of x. Boy, I sure hope this is correct. We shall find out here shortly. Okay, so we want to set this thing equal to 0. So we do that. You know, I'm just leaving this 8/3 up here in the numerator because it's not going to matter right now. We have x squared minus 16, and that's all over x squared minus 16. Oh, you know what? No. Stuff all started looking the same there for a minute. I was zoning out, man. All right, so we set the numerator equal to 0. X squared minus 16. Get the solutions for that. So we bring 16 over, and then we have 1/3 x squared. And then we take that, multiply that by 3, and that's going to be 48, right? 32/48. And of course we've got the square root, plus or minus is equal to x. Okay, so that's going to be something we put on the number line for sure. And then the denominator, we've got to make what gives us 0 here is going to be, that's easy enough, we'll just do that right here. That's going to be x is equal to plus or minus 4, plus or minus 4. Okay, so there we go, we got our numbers here. Now what we're going to want to do now is a number line, and Unfortunately, I'm running out of room down there. Okay, question is, what is the square root of 48? Actually, what I'm going to do here is get a new sheet of paper. Let's remember these numbers here. Shoot. Okay, and I'm going to rewrite all this stuff on another sheet. Alright, we just kind of run out of room there, so let me just rewrite that derivative. We had f double prime of x is equal to, we had 8/3 up here, and then 1/3 x squared minus 16, and then that was all over x squared minus 16 raised to the 4/3 power. Right, 4/3 power. Okay, so we had x is equal to plus or minus 4, and then we had also x is equal to plus or minus the square root of 48. Of course, we could break this down, but to know approximately what this is, I think it was 6.93 or something like that. Square root of 48, plugging that in, yeah, 4 times the square root of 3, technically. We got 6.92. Okay, so this is approximately, so we know on the number line where we're at anyway, plus or minus. Alright, so let's go ahead, draw our number line. Okay, so we're going to have a negative 6.9, we'll just say. We're going to have a negative 4 and a positive 4, and then 6.9 positive. Right. Okay, so what we'll do here is we'll go ahead and plug in a negative 7. That's going to be one of our test points, and then negative 2 is a good test point. Positive, let's do 0, since 0 is between negative 4 and 4. And wait a minute, that can't be 2. How about a 5? Can't even read my own writing. Okay, and then we'll do 5. Here's a test point, and then we'll do a 7 over here as another test point. So we take negative 7 and we plug that into the derivative. So f double prime of negative 7, right? And all we care is if this is negative or positive. So we plug this in, we end up getting 49, so we know this is going to be a positive number down here. Plug it in up here. We end up getting 49, a third of 49. Is that going to be bigger than 16? A third of 49. Good question. Yeah, actually it's 16.17. So this is going to be a positive number. So this is going to be plus. And that means that the graph is increasing up to this guy right here, which is actually the square root of 48. Okay, let's remember that. And now we take a negative 5 and plug it in, right? So that's going to be 25, so that's going to be positive. And then that's going to end up being 25, and a third of 25 is going to be 8 point something, and that's actually going to be negative. Okay, that'll be a negative number, so we know that's concave down. Now I suspect that when we plug 0 in, we should get concave down also. So we plug 0 in here. Now that's going to be a positive number because of this 4 right here. So it'll be positive in the denominator. When we plug 0 in up here, you can see that we're going to get negative 16 times 8/3 is negative. So that's going to be a negative, and I suspected that, right, by just looking at the graph. And then we plug 5 in, we should get positive. So it's going to be 25, that'll be positive. And then once again, because it's squared, it won't matter since we've already done negative 5, right? So that means that's negative, okay? And that's concave down. And boy, and then we do 7, that should be just like negative 7. Okay, that's 49, that's positive, and then that's going to end up being positive there. So that's positive. Now we can tell where our inflection points are occurring. They're occurring here and here because you have to have a change in concavity. We don't have a change here and we don't have a change here, right? But I forgot what the question actually was. Find the concavity of the graph. Okay, what the heck we were doing. So as you can see here, we're going to end up with concave up. So let's just write this out. Concave up from negative infinity. And I'm going to go ahead and write. Now you can break this down. This, what is this? This is, let's see, 12 and 2. Let's see. Square root of 3 times, I believe the square root of 48. Yeah, it's 4 times the square root of 3 actually. So this becomes negative 4 square roots of 3. Yeah, concave up. And then of course we'll have to union it with this part of the concave up. Union, that's supposed to be a U there actually for union. And then this would be 4 square roots of 3 to infinity. Okay, 4 square roots of 3 to infinity. And now concave down, right, is going to be between these two numbers. Now we can't include this. Okay, we cannot include negative 4. You must understand that because that's not in the domain of, it's not concave down or up at negative 4 right here. But we'd say negative 4 square roots of 3 comma 2 negative 4, right, is concave down union, and then from negative 4 to 4, and then union from 4 to 4 square roots of 3. You can see, okay, that it's concave down. Alright, so that's kind of a long problem there, but we got to work that out slowly so you understand what's going on. Okay, let's go back to the web page and take a look at what they got. Okay, so let me kind of flip back and forth here. So concave up, negative infinity to negative 4 square roots of 3 union 4 square roots of 3 to infinity. Square roots of 3 to infinity. Okay, that looks good. Negative 4 to right. Okay, we're just making sure everything's correct there. Okay, so it all looks good, and like Anthony Zimmerman says, if it all looks good, eat it. Anyway, alright, so we're over here at gotomath.com. Check it out, practice that problem, try to do it in under 3 minutes if you can. Okay, alright, and I'll talk to you later.